Let's review another exponent law relating to negative exponents. Ten to the 4 divided by 10 to the 5 creates this quotient form. There are 4 tens on top, 5 on the bottom. So this would equal 10 to the 4 minus 5. The result is 1/10, or 10 to the negative 1. So on top, all of these would cancel out to make 1, and there would be 1/10 left on the bottom, so 1 over 10. 10 to the 2 divided by 10 to the 5. These two tens cancel out these two tens, so we have 1 on top and 10 to the 3 on the bottom. So 10 to the exponent 2 minus 5 is 1 over 10 to the 3, or 10 to the negative 3. 6 to the 1 divided by 6 to the 5, here it is in quotient form, will result in 6 would equal to 6 to the exponent 1 minus 5. So that's 1 over 6 to the 4, which is 6 to the negative 4. 2 divided by 2 to the exponent 3 looks like this. These 2's will cancel each other out, so we'll be left with 1 on top and 2 to the exponent 2 on the bottom. Another way of writing it is 2 to the exponent 1 minus 3. So here's 1 over 2 to the 2, or 2 to the negative 2. So any number to a negative exponent looks like this. The base of a to a negative n is equal to 1 over a to the positive n. Here's some examples. X to the negative 3 is equal to 1 over x to the 3. Negative 5 to the negative 12 is equal to 1 over negative 5 to the 12. And 2 to the negative 1 is equal to 1 over 2. Let's do a quick review and consolidate what we just learned. The product law. When multiplying identical bases, you simply add the exponents. So a to the n times a to the m is equal to a to the n plus m. The quotient law. When dividing identical bases, you simply subtract the exponents. So a to the n divided by a to the m is equal to the a to the n minus m. Negative exponents. A to the negative n is equal to 1 over a to the n. Zero exponents. Anything to the exponent 0 is equal to 1. So a to the 0 is equal to 1. Let's explore exponential functions. We're going to sketch two equations. The first that we'll sketch will be y equals x squared, and the second is y equals 2x. Notice we've reversed the base and the exponent. So x and 2 become 2 and x. We're going to begin by creating a table of values. So when x is equal to 5, x squared is 25, but 2x, or 2 to the exponent x, is 32. For x equals 4, x squared is 16, but 2 to the 4 is 16. So they're the same. For x equals 3, x squared is 9, but 2x is 8. For x is 2, x squared is 4, while 2 to the exponent x is 4. When x is 1, x squared is also 1, but y equals 2 to the exponent x is 2. When x is 0, x squared is 0, and 2 to the x is 1. When x is negative 1, x squared is 1, and 2 to the x is 0.5. When x is negative 2, x squared is 4, but 2 to the x is 2 to the negative 2, which is 0.25. For when x is negative 3, y equals x squared is 9. For 2 to the x, 2 to the negative 3 is equal to 0.125. When x is equal to negative 4, x squared is 16, but 2 to the x is 0.0625. Finally, when x is negative 5, x squared is 25, and y equals 2 to the x is 0.03125. Here's our table of values completed. Looking at this point, and these red points correspond to y equals x squared. The blue points, here is our parabola for y equals x squared. Our blue points show y equals 2 to the x. Here is the curve for y equals 2x.